Now we're going to start the dividing polynomials set of notes, and this video is just going to focus on long division. Before I start on polynomial long division, though, I do want to maybe go back and think about how division of integers works. So maybe let's think about 40 divided by 3. Let's think about how we computed this, and let me introduce some terminology that we're going to be using. So the thing on the inside, that's the thing that's being divided, I'm going to call that the dividend. And then the thing on the outside, which we're dividing by, I'm going to call the divisor. So this is dividend and divisor. So we're going to take the dividend and divide by the divisor. The resulting thing should be the quotient. So this thing up here, I'm going to call the quotient. We'll also get a possible remainder term. Okay, and those are the same words that I'm going to be using whenever we start to do polynomial long division. But now let's compute this quotient. So what we first do is we'll take this 3 and try to divide it into this first term, which is this 4. So I want to know how many times a 3 fits into a 4, and it fits in once. So I've now found this first term in my quotient. Okay, so as soon as I find a term in this quotient, so I found this one digit in the quotient, as soon as I find that, what I have to do is I take this and multiply by the divisor. So I'll have a 1 times a 3, which gives me a product of 3. And then I subtract that off in order to compute the remainder so far. So I'll have a 4 minus a 3 gives me a 1. Now 3 doesn't fit into 1. 3 will never fit into that remainder. So what I'll do is I'll bring down the next digit, which is a 0. And then we repeat this process. So now the question is, how many times does 3 fit into our current remainder, which is 10? So what is 10 divided by 3? Well, 3 fits into 10 3 times. And again, as soon as we find some term that belongs in the quotient, we take that number and we multiply it by the divisor. So we'll have a 3 times a 3, which is a 9. So we compute that product. And then once we have that product, we'll subtract it off to compute the remainder. So we'll have a 10 minus a 9, which is a 1, and that's our remainder. So this is what I'm going to call the remainder, and this up here is what I'm going to call the quotient. And notice that there is a certain relationship between all of these numbers, namely that our original dividend can be written as our divisor times our quotient plus our remainder. And if you look at the dividing polynomials set of notes, you'll see this as the dividend can be written as the divisor times the quotient plus the remainder. This formula is going to remain true even for polynomials. So that's sometimes useful for polynomials. So what we're going to do now is we're going to start on polynomial long division, which is where we're applying the same procedure, but this time dividing one polynomial by another. Now there is a procedure that we're going to be following, and it's in the middle of this first page of your notes. And if you'd like, you can pause the video and read over that procedure. It might be better to just go through an example with me before pausing and thinking about the procedure. I think it might be more instructive to just do as many hands-on examples as we can, but if you'd like, you can read over the procedure that we're going to be using. There's also a typed up example, actually a couple of typed up examples in the notes. So if these next steps are confusing to you, feel free to just pause the video and read over some typed up examples as well. But let's just dive in with example 1a. Here we have this quadratic, x squared plus 3x minus 10, and we're supposed to be dividing that by x minus 2. Now, if we take this and divide it by x minus 2, that's the same thing as saying that this x squared plus 3x minus 10 is our dividend, and our divisor is x minus 2. So I want to compute this quotient. And the way that I'm going to do that is this. What we do is we will just compare the highest order term on the inside with the highest order term on the outside. So I'm just going to first focus on the x squared, and I want to know how many times x will fit into x squared. Just like in the previous example, I wanted to know how many times did 3 fit into 4. So I just compared the first terms, or the first digits, from the previous example. I'll do the same thing here. So I'm just going to compare the x and the x squared. Now to do that, I'll take x squared and divide it by x. So if we take the largest term on the inside and divide it by the first term in the divisor, I'll get x squared over x is just equal to x. So that quotient will become the first term in my quotient. So in other words, the first term in your quotient will just be whatever you get whenever you take the first term on the inside and divide it by the first term on the outside. Okay, now here's where things get a little bit complicated. So what we have to do is, now that we've found a term in our quotient, we have to multiply that term in our quotient by our entire by our entire divisor, which is this x plus 2. We'll compute that product and then we'll subtract it off. And notice that this is the same thing that we did up here in this example with real numbers. So here I had 1 as our first digit in the quotient. I multiplied that by the 3, and then I subtracted it off. So I had a 1 times 3, which was a 3 here, and I subtracted it off. I'm going to do the same thing here. So I'm going to multiply x times x minus 2. And we need to do this term by term. So x times x is an x squared. X times a negative 2 is a negative 2x. That's the product that we got. And now I need to subtract it off to compute the remainder. And notice that the entire product will get subtracted off. So this minus sign outside is going to apply to that entire product. And if you line things up column by column, then you'll have like terms in each column. So this first column will be an x squared minus x squared, which is 0. If you'd like, you can write 0x squared. For the next column, we'll have a 3x plus a 2x, because there are 2 minus signs that apply to this 2x term. So this would be a 3x plus a 2x, which is a 5x. So we get a 0x squared plus 5x. Okay, and now we'll do the same thing that we did with numbers, which is we can bring down any remainder terms that exist up here, or any of the other terms. So now we have 0x squared plus 5x minus 10 is our current remainder. And now, just like we did with ordinary numbers, we're going to continue this process. So we're going to start over at this stage. I want to know how many times does x minus 2 fit into 5x minus 10. So you can ignore the 0 term if you'd like. And again, the process is similar. What we do is we take the highest order term of the current remainder, and we divide by the highest order term of the divisor. So this would be a 5x over x, which ends up just being 5. And that will be the next term in the quotient. So this will be an x plus 5. 5 is the next term in the quotient. And we're going to do the same thing we did with numbers above. Once you find a term that belongs in the quotient, you're going to take the product of that term. So we'll take the product of 5 and your divisor. So this is going to be 5 times x minus 2. And again, we'll compute this product term by term. So we'll take a 5 times x, and then a 5 times a negative 2. That's the product that we get whenever we take the term that we found above times our divisor. And now we're going to subtract this off. So this would be a 5x minus a 5x, that would be a 0x, and then a negative 10 plus a 10, which is a plus a 0. And now, just like above, this last number that you get whenever you reduce to just an ordinary number down here, this represents the remainder. So here 0 would be the remainder, but the quotient is this entire thing up at the top. So this is still the quotient. So we're going to have x plus 5 is the quotient. Okay. So the remainder is 0 and x plus 5 is the quotient. Okay, so the procedure is pretty similar to what we would do with ordinary numbers. The only downside is that we have to do some polynomial multiplication along the way. So I think let's do another example like this, and then after this example, if you need to pause the video and read over some of the notes to help you along, then that's totally fine. So let's maybe look at the next one. And I'll change colors just for the fun of it. All right, so now let's look at 1b. In 1b, we're trying to compute this quotient. Looks like it's an x to the fourth. Whoops, I don't want to do that. Sorry, I just needed to leave a little bit of space here. So I want x to the fourth plus 2x cubed minus 4x squared minus 5x minus 6. And that's our dividend. Our divisor is x squared plus x minus 2. Okay. So now we're going to compute this quotient. The strategy is exactly the same as above, though. All that we're going to do is we're going to take the highest order term on the inside and divide it by the highest order term on the outside. So if you'd like, you can do that with scratch paper. I sort of expect that you'll start doing it mentally as you get comfortable with it. But if we take x to the fourth divided by x squared, that quotient would be x squared. So that'll be the first term in our quotient. And then once we find a term in the quotient, we multiply by our divisor. So we're going to multiply that x squared times all of this stuff over here, and then we'll subtract it off to compute the remainder. So I'll get an x squared times x squared, which is x to the fourth, x squared times x, which is an x cubed, and then an x squared minus 2, or sorry, x squared times minus 2, which is a negative 2x squared. So that thing in parentheses is the product, and now that we've multiplied, we can subtract that off to compute the new remainder. So notice that this minus sign out here is going to apply to all three of these terms. So we'll get an x to the fourth minus x to the fourth. That gives us a 0 in the first column. This should always happen, assuming that you're choosing your quotient term correctly. So this first term should always be 0. Next, we'll get a 2x cubed minus an x cubed. So that would give us an x cubed. And then lastly, we would have a negative 4x squared minus a negative 2x squared. So these two minus signs would combine to give us a positive 2x squared in the, for the second term. So altogether, we should get a negative 2x squared when we add those columns together, or those rows together. And then we can bring down these other terms if you'd like. So this is still part of the remainder. We have a negative 5x minus a 6. So I like to go ahead and bring down all of those terms. It's sort of optional to do that at this stage, but you do need to remember that those terms are still up there. Okay, so that's the first term in the quotient, and this is our current remainder. So now we repeat the procedure. So we're going to take the highest order term on the inside and divide it by the highest order term on the outside. If we take x cubed and divide it by x squared, that's just an x. And again, that represents the next term in the quotient. So we'll have an x squared plus an x. And now that we've found this new x term in the quotient, we're going to multiply that by our divisor. So I need to take this x up here and multiply by x squared plus x minus 2. And then I'll subtract that off. So when I multiply x times x squared, I get x cubed. When I multiply x times x, I get x squared. And then x times negative 2 is a negative 2x. That's the product in parentheses, and then I need to subtract that off to compute the new remainder. So this would be an x cubed minus x cubed, which is 0. Again, that's always supposed to happen in that first column. Here in the next column, I have a negative 2x squared minus an x squared, so that would be a minus 3x squared. Next column is negative 5x plus 2x, which would be a negative 3x, and then I like to bring down that last term, so a negative 6. So now we've made it to our new remainder. This is our new remainder, and now what we're going to do is we're going to take the highest order term on the inside, which is a negative 3x squared, and divide it by an x squared, because that's the highest order term on the outside. So a negative 3x squared divided by x squared is just a negative 3. So we'll get a negative 3 here. And now I need to multiply that negative 3 by all of the terms in the divisor. So I would get a product of negative 3x squared minus 3x plus 6. Whenever I multiply negative 3 by all three of those terms in the divisor. And remember, I'm subtracting this off. So we take that full product, whatever we get whenever we multiply that new term by our divisor, and we subtract off that full product. So this first column should be a negative 3x squared plus a 3x squared. So that would be a 0. And then we have a negative 3x plus a 3x, which is also a 0. And then in this last column, I have a negative 6 minus 6, which is a negative 12. And remember that whenever we make it to this stage, notice that an x squared does not fit into negative 12. So as soon as this term, this first term in your divisor, does not fit in to whatever your current remainder is, this part is just called your remainder. So in this case, our remainder is negative 12. And then whatever's left up at the top here is your quotient. So our quotient is x squared plus x minus 3, and our remainder is a negative 12. Okay, and that's all that we're looking for. Anytime I ask you to compute a quotient like this, I just want you to write down what the quotient is, which is x squared plus x minus 3, and then whatever the remainder is if there is a remainder. So this would be an acceptable answer to that problem. Okay. So we're going to do the same thing a couple more times. I am going to go a little bit more quickly through these, so if you need to pause the video to do some scratch work on your own, or maybe if you can slow down the video, then that's totally fine. But just to keep this video a little bit shorter, I'm going to go through these somewhat quickly. So in 1C, and by the way, I'm also going to be posting an alternative set of handwritten notes for these. So if you'd prefer to just read over those rather than complete the rest of this video, that's also fine. But I'm going to go ahead and finish 1C and 1D. So in 1C, what we have is 5x cubed minus 4x squared plus 7x minus 2, and we're trying to divide that by x squared plus 1. Okay, now remember that we're going to take the biggest term on the inside, or I should say the highest order term on the inside, and divide it by the highest order term on the outside. So that's going to be a 5x cubed plus divided by an x squared. Notice that in all of these problems, I am writing both of these polynomials in descending order by degree. So I have the cube, and then the square, and then the single degree term, and then the 0th degree term. And the same thing happens out here. So you want to write these in descending order of degree, otherwise this procedure doesn't work quite as cleanly. So it's best to rearrange these so that the degrees go from highest to lowest in both of the terms. Or in other words, the powers go from highest to lowest in each polynomial. Okay, so first we're going to take 5x cubed and divide by x squared. That would give us a quotient of 5x. So that's the first term in our quotient. To compute the new remainder, I'm going to take that 5x and multiply it by our divisor out here. When I do that, I'll get a 5x cubed for the first term, and then a 5x for the second term. Now notice that things are a little bit weird here. The second term is just a 5x times 1, which is 5x. This doesn't quite belong in this column. So it's good to arrange the columns so that they correspond to like terms. So this first column is the cubic column, and then there's the quadratic column, and then the linear column, and so on. So I'm actually going to erase this just so that we can keep the columns in order like we want. So I think this is a good practice for you. So I would write this product as a 5x cubed plus a 5x, but I would want to keep the 5x in the appropriate column here so that whenever I do subtract off this product, I can subtract off the like terms appropriately. So here in the first column, I'll have a 5x cubed minus a 5x cubed. That would be 0. In the next column, I'll just have a negative 4x squared. In the next column, I'll have a 7x minus a 5x. So that would be a 2x. And then I'm going to bring down that last term, which is a negative 2. So this is our current remainder. And next, we'll follow the same procedure again, but starting with this as our highest degree term for the remainder. So we have a negative 4x squared divided by an x squared. That would just be a negative 4. So that'll be the next term in our quotient. I now multiply that negative 4 by both of the terms in our divisor. So that would be a negative 4x squared for that first product, and then a negative 4 times 1. And again, that belongs over here in this column, because it's not a like term with this 2x. Instead, it's like, it's like the negative 2 over here. So this thing in parentheses is the product that we just computed, and we need to subtract that off to find the remainder. So here I have a negative 4x squared plus a 4x squared. That would give me a 0. And then in the next column, I would have a 2x. And then in the last column, I have a negative 2 plus a 4, which is a positive 2. Now notice that here we have 2x as the highest order term in the remainder, but x squared is too big to fit into that. In other words, x squared does not divide evenly into 2x, because x squared actually has a higher power than our current remainder. So in this case, x squared just doesn't fit into 2x at all, and that means that this whole remainder expression is actually the remainder for this division. So the remainder in this case is 2x plus 2. So the important thing in this example is that the remainder is not always just a number. The remainder can be any polynomial that's smaller in degree than your divisor. So in this case, because x squared does not fit into 2x, we just call this whole thing the remainder. And similarly up here, this whole thing is going to be our quotient. And it's okay with me if you leave your answer in this form. So you don't have to rewrite the quotient and the remainder down below. As long as you box them and call them the appropriate things, this is fine with me. Okay. So lastly, let's look at 1D. Whoops. So in this one, we have x to the 4th, and then a minus 16x squared, and then a plus 1. You may notice that I've spaced these out a little bit. That's deliberate for a reason that I'll show you in just a second. We're dividing that by x plus 4. So let's go with the usual procedure here. We want to take the highest order term here and divide by the highest order term out here. So that would be x to the 4th divided by x, which is an x cubed. And now I'm going to take the product and subtract it off. So this would be x cubed times x, which is x to the 4th, and then plus an x cubed times 4, which is a 4x cubed. That's the product that we get, and I need to subtract it off. But notice here that x cubed and x squared, these are not like terms. So actually, this x cubed belongs in a sort of middle column here. So there's a 0x cubed here, and similarly, there's like a 0x here. So if you'd like, you can fill in zeros anywhere there's sort of a missing degree so that the degrees are strictly descending, like 4, 3, 2, 1, 0. Okay, so in reality, this you just have to be careful that you don't subtract this last term from the 16x squared, because it's really a cubic term, and so it should be subtracted from this cubic column, even though that cubic column wasn't there originally. So it's okay to fill in new columns with zeros if you'd like. If you don't want to fill in with zeros, just pay careful attention to what you're doing whenever you subtract off. Make sure that you're actually subtracting off like terms. So here you shouldn't do negative 16x squared minus 4x cubed, because those are not like terms. So it's probably easiest to just arrange so that you have a quartic column, and then a cubic column, and then a quadratic column, a linear column, and then a constant column, like I've done here. Okay, so we'll have x to the 4th minus x to the 4th, that's a 0, and then a 0x cubed minus 4x cubed, that would be a negative 4x cubed. Okay, and then the rest of these can be brought down as the rest of our remainder. So we'll get minus a 16x squared, plus a 0x, and plus a 1, and this is our current remainder. And now we'll proceed as usual, so we're going to take this term and divide by x, which is the highest degree term out here in our divisor. So a negative 4x cubed divided by x would be a negative 4x squared, and now we compute the product and subtract it off. So if I multiply that by x plus 4, I would get a negative 4x cubed, and then a negative 16x squared. That's the product that I get if I just take the new term that we just found in the quotient and multiply by the divisor. And now I need to subtract that off. Now if I do the subtraction in the first column, I get a 0. Doing the subtraction in the second column is also a 0. The third column also gives me a 0, and then bringing down the 1 will give me the remainder term. So notice that here x plus 4 does not fit into this term, so this term must just represent our remainder, and the stuff up here represents the quotient. Okay, and that concludes the long division examples. In the next video, I'll show you kind of a shortcut that you can take for computing these whenever you're dividing by something like this, x plus 4.